In this chapter, I want to talk about chemical reactions. First, let's determine what a chemical reaction is. We can say that a chemical reaction has occurred when a new substance is formed by the formation of a new bond. So if we had A bonded to B, plus we had atom C, and a new substance was formed where A is bonded to B, and B is bonded to C, a new substance would be formed, and we could say that a chemical reaction occurred. Conversely, we can say that a chemical reaction occurred when a bond is broken and a new substance is formed. So let's take a molecule where we have A bonded to B, bonded to C, and we broke the bond between B and C, and we arrived at a molecule where A was bonded to B and we had C that was not bonded to the molecule. We could say that a chemical reaction occurred. So to answer the question, what is a chemical reaction? We can say that a chemical reaction occurs when new bonds are formed, like right here, or when bonds are broken, like right here, to form a new substance. We said that a chemical reaction occurs when new bonds are formed or bonds are broken to form a new substance. Let's take a look at exactly what it means to form a bond and to break a bond using Lewis dot structures. Let's use the generic atoms R and X to make a molecule where R has 8 valence electrons and X has 7 valence electrons. And let's make another molecule XR, where X has 7 valence electrons and R has 8 valence electrons. In order for a bond to be formed, there has to be an electron available to be donated, and there has to be a space where that electron can go. Looking at the generic molecule Rx, we can see that there's a single electron, and we can use that as a donating electron. And on the other molecule, looking at the X atom, we can see that there's 7 valence electrons, leaving us a space for an electron to be accepted. So we draw an arrow from the donating electron going to the place where the electron is accepted. We can then say that a new molecule is formed, or a new substance is formed. When we take a look at how bonds break, we can use these two electrons that would bond the two X generic atoms together right here and describe this as one electron would then go to one atom and another electron would go to another atom. From the bonds that were broken, we could then say that we got two new substances, one here and one here. And this would fit the description of a chemical reaction. I should point out that when one electron is transferred, this is called a heterolytic reaction. Reactions can also occur where both electrons will go to one atom or the other, like this. When both electrons are transferred, it's called homolytic and it gets a double-headed arrow. Let me fix this. This should be right here. We know what a reaction is and how it occurs. Now I want to talk about why a chemical reaction occurs. A chemical reaction occurs from some form of energy. That could be in the form of heat, light, vibration, and many other forms. The reason why bonds are formed or broken in a substance or molecule to make a new molecule is because some form of energy has been applied to it. And if we use this as a diagram to show the path the substance or molecule would take when energy is applied, the energy goes to a maximum here where the X is, and then it decreases until we have a finished product. So what that means is the energy difference between this dotted line and the X would be the amount of energy it would take to surpass the energy that the two bonds have that hold it together. This added energy would distort the bonds between the two atoms by stretching the bonds and vibrating the bonds to a point where they break. Likewise, we could say that this is the point where atoms or molecules collide and overcome the forces that are in the existing molecule to form new bonds where they kind of snap into place and then a new substance is formed. When one thing changes into something else chemically, we can represent this by what is called a chemical equation. A chemical equation gives us kind of a shorthand or abbreviated framework to account for and follow what is happening in a chemical reaction. This can be thought of as a bookkeeping-like record of a chemical reaction. We can set up this equation by first writing down what we start with, which is termed the reactant. We draw an arrow pointing to the right. like this. This symbolizes the change from one substance to another. We can also put other chemicals or parameters down. Usually these are conditions that aren't directly involved in the reaction that we're focused on. After the arrow on the right, we write down the new substance or what we get. We call this the product. This is basically how to write a chemical equation. Now that we know what a chemical reaction is and how and why a chemical reaction occurs, let me show you some of what I'm going to go over in Chapter 4. In Chapter 4, I'll go over the definitions of chemical reactions. This is important because when definitions are established, the language we use becomes more clear, and the concepts we go over can be interpreted with more meaning and confidence. Definitions kind of gets everyone on the same page to use a common language. This makes it a lot easier to communicate ideas. Along with definitions, I'll go over balancing equations, reactions and aqueous solutions, oxidation and reduction, voltaic and electrolytic cells to show energy and electron flow. I'll go over molecular and empirical formulas, moles, Avogadro's number, molar mass, stoichiometry, limiting reactants, percent yield calculations, and last I'll go over energy and reactions. In this section, we'll go over energy that's exothermic and energy that's endothermic.